Hey, welcome to Zona Mechanica. There is an MCQ on principal stress. Figure at the margin indicates the weightage of the question, that is 2 marks. A solid circular shaft of diameter 100 mm is subjected to an axial stress of 50 MPa. It is further subjected to a torque of 10 kN meter. The maximum principal stress experienced on the shaft is closest to. There are 4 options: 41 MPa, 82 MPa, 164 MPa, 204 MPa. Well, let this is a solid circular shaft of diameter d. So diameter is d, and an axial stress is acting. Let sigma a be the axial stress, and a torque of 10 kilonewton meter is acting. So let T be the torque acting, is 10 kilonewton meter. Okay, and sigma a is equal to 50 MPa. Okay, so the question is, what is the maximum principal stress acting in the shaft? Okay, so diameter given, d is equal to 100 mm, that is equal to 0.1 meter. Okay, due to this torque T, the shaft will experience a shear stress. Let tau be the shear stress developed in the shaft. So from the torsion formula, we know T by J is equal to tau by R. All the symbols are bearing usual meanings. So from here, this shear stress tau is T by J into, so T is torque 10 kilonewton meter, so 10 into 10 to the power 3 Newton meter. Okay, and J is polar moment of inertia, pi by 32 into d to the power 4, and R is d by 2. Okay, so tau is equal to 16 into 10 to the power 4 divided by pi into d to the power, sorry, here d in capital, so d to the power 3. Okay, that is 16 into 10 to the power 4 by pi into 0.1 to the power 3. So this will give some 50.929 into 10 to the power 6, this much of pascals. So which is almost equal to 51 megapascals, right? Into 10 to the power 6 is there. Okay, so we got tau. So now from the expression of principal stress, we know sigma 1 2, that is maximum principal stress and minimum principal stress. So it is sigma x plus sigma y by 2 plus or minus root over of sigma x minus sigma y by 2 whole square plus tau xy square, right? This is the expression for principal stresses. So for the maximum principal stress, we will consider plus sign. Okay, so sigma max will be this. Sigma x, here we have a single axial stress, so sigma a, and sigma y will be 0. Okay, for our case, so sigma a by 2 plus root over of sigma a by 2 whole square plus tau square, right? So sigma a is 50 MPa, so 50 by 2 plus root over of 50 by 2 whole square plus 51 square. So all are in MPa, right? So this will give 81.79 MPa, which is almost equal to 82. That is closest to 82 MPa. So clearly it's matching with option B. So option B is the correct answer.